For those of you that are not sitting in the first row, there is money taped under the chairs.
It's on.
Yeah. 2:30. Okay. Okay. Good afternoon, everyone. I hope that you had good lunch, and hopefully that our afternoon section will not make you sleepy. Okay, welcome to section 3, deep dive into life cycle refrigerant management on the leak prevention. And my name is Pipat, interim Montreal Protocol regional coordinator of the Southeast Asia and Pacific Islands Network country of Ozone Action, UNEP Ozone Action, based in Asia and Pacific office in Bangkok. Facilitator of this breakout group. In the next 75 minutes, this breakout group will discuss leak prevention as a component of life cycle refrigerant management in a greater details. The focus will be on available and emerging technologies and practices for leak prevention, existing regulatory approach, and gaps in current policy in relation to leak prevention, and practical strategy and solution for effective leak prevention. Participants will be able to discuss key issues and challenges related to leak prevention, starting from the design, manufacturing, installation, commissioning, and operation of equipment, including servicing sector needs and approach for addressing those needs. The breakout group will aim to share instructive examples and identify actionable recommendations for policymakers and industry. I would like to urge all participants to feel free not to only ask the question, but also share your experience and your feedback to make this section interactive. Today, it is my great pleasure to have our tea expert joining our section. First, let me introduce Mr. Rajan Rajendran. He is a co-chair of the Refrigeration, Air Conditioning, and Heat Pumps Technical Option Committees, or RTOC, and is a member of the Technology and Economic Assessment Panel, or TEAP. Second, I would like to introduce Mr. Glenn Evans on my left-hand side. He is the Chief Executive Officer of the Australian Refrigeration Council, or ARC. And third, Mr. Jitendra Bambure. He is a RTOC member and was a TEAP task force member on energy efficiency and life refrigerant management. More information on biography of our resource person can be found on the website of this workshop. Thanks so much, Rajan, Glenn, and Jitendra for joining us in this section. We will start the section with an overview presentation by author of the TEAP Task Force report, and then we will follow by the panelist section, which we will allow participants to ask your question. And the presentation is also available on Ozone Secret website, and you can also take a look from the website as well, apart from the screen here. Okay, now may I invite Mr. Rajan to make your presentation, and I over to you, Rajan.
Thank you, Pipit. I was one of the authors, along with many, on that report. So, welcome everybody. Thank you for being here. What we're going to do today is do a deep dive on leak prevention. And the content that I have here that I'm going to share with you over the course of the next 5 to 6 minutes is content that is taken directly out of the report. So I'm just going to lay the groundwork. And once that is done, we'll get into the discussion with Jitendra and Glenn and Pipit and all of you joining us in the conversation. So when you talk about leak prevention, there are 3 definitions that we have to get out there and make sure that we all are clear on what these are. The first and foremost one, of course, is what do you mean when you say leak prevention? It is the avoidance of potential refrigerant loss when during the entire equipment's life cycle. So basically from start to finish, you avoid refrigerant loss. That is what we mean by leak prevention. But leak prevention doesn't go by itself. There are 2 other terms that we need to understand as well. One of them is tightness inspection. It refers to verifying whether the refrigerant may leak from the equipment at any time, whether it's manufacturing, installation, commissioning, or the use. And one of the ways we verify, or 2 of the ways we verify, is to use either indirect methods or direct methods. We'll talk about this in just a little bit. Once you know that when you're looking for a leak, if you do find a leak, you have to identify the precise location of the leak in order to fix it. That leak identification and location is very often, almost always, done with a direct leak detection method. And that's the reason why we're going to be talking about these 2. So what are these different leak detection methods? One of them is obviously the indirect method, and the other one is the direct method. What do I mean when I say indirect? What I mean by that is you're using the system parameters. If it's controlling temperature, then it's temperature, pressure, current, and so on and so forth. You use the system parameters to find out if something is out of the ordinary, something that does not meet your expectation. This is the kind of thing that equipment manufacturers have data on, and so indirect methods invariably come straight out of the box in the controllers or software that they use. Indirect methods are also very often used in very large systems, commercial air conditioning as well as commercial refrigeration systems like grocery stores and so on. Direct methods are where you actually have a tool in your hand and you go looking specifically for a gas. It tries to sense the gas, either see the gas in some way or the other. There are many, many different, this is just a handful of ways in which direct methods, direct tools that will actually come in handy. I'm only going to talk about 3 of them in here. One of them is this handheld sensor that actually looks for it, because this is very often used in the final step before you find and before you fix a leak. The other type of detector is what is called the remote automatic leak detectors. These are a little bit more general. They will only tell you that there is a leak out of this piece of equipment, and again, it's used more often in very large systems. And finally, probably the one that is least technical, but it works really, really well, and technicians love it, is the soapy water. So you go and you spray it on a joint, and if there's a leak, you see bubbles. Nothing like a visual signal for you to know precisely where the leak is happening. So these are some of the ways in which you detect, and many of these are actually used in all these different stages or phases of leak prevention. During design, of course, manufacturing, transportation and storage, installation, and the actual use of a piece of equipment. End of life is not addressed by us because you've got a whole different section where they talk about that. So how do you prevent leaks during design? The way you do that is to make sure that your design follows all the appropriate engineering principles to minimize vibration, to minimize friction, to make sure you're using all the right materials, the right thickness of the materials, make sure you take into account what the specification of the product is, whether it's going to be close to water, close to the ocean, or it's going to be in a corrosive environment, et cetera, et cetera. You take all of that into account and you design the proper product that you need. All these are there in those guidelines that we mentioned here. And one of the things that a good design has to do all the time is to make sure that you do a failure mode and effect analysis specifically for leak, okay? Once you're done with the design, and once you know that you have a good design, you have to go through the manufacturing process where you're actually buying components or making components, multiple components, and putting them together, assembling them, brazing them, welding them, torquing them, et cetera, et cetera. And all of those joints have to be leak-free. And during the manufacturing process, I'm not expecting you to read all this in detail. It's all there in the report. But notice those 4 boxes. They're spread out during the manufacturing process to make sure that at every stage you ensure that you don't have a leak, or you have a leak-free component, and then you move it to the next stage. Once you're done with the manufacturing, then you need to transport it. Transportation involves vibration, road vibration. A good design will take into account transport vibration, but even with the best design, you still need to make sure that your packaging is appropriate, and therefore packaging design is also crucial. Make sure that you're not going to break a tube or two during transportation. People do vibration tests and drop tests and so on packaging. These are all done very commonly in high volume production. They may not be done in individual one-off systems, and for those you have to follow a few other different steps, but all these are detailed in some of these standards, and I know Glenn will draw your attention to some of them as he speaks to this. Once you transport it, you now have to install it, and installation becomes the most important step. No matter how good the piece of equipment is, if you install it poorly, it is not going to perform well, and leaks are definitely going to happen. Make sure that you have good air circulation around the condensing coils and such, because you do not want condensing pressures to be much, much higher than what the design pressure says it should be. And of course, it is extremely crucial that this installation be done by trained and competent service technicians who know exactly how to install this piece of equipment and actually commission it. During the use of the product, you're going to be, using indirect methods to make sure that your performance is what you should expect. And if it is not meeting spec, then maybe alerting a service technician to come over and take a look at it, or you should be doing preventive maintenance, which is every so often, clean the condensing coil, check the various parameters in the system, and for this you have to have a contract with a service technician to come in and take care of it. So these are all spelled out in many of these standards, and again, I cannot emphasize, I think I've said it 2 or 3 times already, the service person is critical in this whole process. So with that, I'm going to stop and turn it back over to Pipet so that we can go on with the discussion. Thank you.
Thank you, Rajan, and thanks a lot for your comprehensive overview of the leak prevention and that discuss about tightness identification, inspection, and also leak identification. And we'll cover all the process, start from the design, manufacturing, transportation, and storage, packaging, installation, commissioning, and also until the use and operation of equipment. And okay, now the floor is open for participants, but before you ask, you might need to get a couple minutes to think about the question. And I have the question in between to ask T of our panelists that one of the common finding when we did the survey for the country during the preparation of the project is leakage. And the technician always top up refrigerant in their equipment. And they all claim that because of the corrosion and also the joint is not tightened. So if you can give me more explanation about what are the reasons that attribute to this kind of high corrosion of equipment, and that would be helpful for the country. And some countries, they have really extreme climate condition that might attribute to contribute to the corrosion problem. And some country, the lifetime of equipment is only 1 or 2 years, and that you need to replace it again. Yeah, thank you.
Thank you, Pipet. What he's asking about is corrosive environment, especially close to the ocean. Okay, everybody that lives close to the ocean, I did for many years, knows fully well that pretty much everything will start rusting in no time. And there are other corrosive environments that Jitendra and Glenn can talk about, but let me just restrict myself to the ocean example. One of the things you got to do in particular for all of these is to make sure that the equipment that you buy is actually, whether it's the panels or a compressor or heat exchanger, they have to be designed for this, and that includes coating, a paint, or something to reduce the chances or reduce the impact of corrosion. And frequent inspection is also important, because if you catch the corrosion, especially this kind of corrosion will start on the surface and then travel in. If you catch it early enough, you can stop it. But again, I cannot emphasize the importance of checking and making sure that you're using the right product that is actually designed for that environment. That more often than not, that does not happen, and we need to make sure that we do that. I'm going to stop here and turn it over to Jitendra to see if he has any comments. Glenn as well.
So thank you, Rajan. Corrosion is one of the aspects which has not been addressed well, and also very difficult to implement and overcome also in the design because of its nature itself. Rajan spoke about the saline atmosphere, which is at the seashore, but there are many other factors that are there. In urban city centers where exhaust of the vehicle exhaust, which has got high amount of sulfur, is corrosive. If you go to rural areas, we feel that it is a non-corrosive atmosphere, but there can be certain places like animal farms, and the excreta of the animals also is a corrosive atmosphere. One of the recent developments in last maybe 15, 20 years is corrosion of the indoor units, not necessarily the outdoor units. And that is happening because we use lot of material which emits VOCs. It is volatile organic compounds, and these impact the indoor unit, specifically the copper. It is popularly known as formicary corrosion or as an ant nest corrosion, where micropores happen in copper. Our standard belief is copper is close to noble metal, but it gets corroded. Then if you look at certain corrosive effects of microenvironments, like if you install your outdoor unit close to a swimming pool, install near a diesel generator, or of those types, then it becomes a large amount of corrosive effect that has come. The how to prevent that is, we can find a generic solution, and other thing is like we have to find, if it is due to microenvironment, then we have to find a spot-based solution. And the service technician or the installer has to play a big role of where the unit is getting installed. And maybe, in a case, like I said, like a swimming pool, if it just shifts the unit by another 20, 25 feet, it may not happen. And this finally, ends up in the leaks. It's not only copper tubes, but it is also the joints become most vulnerable. And the other part of the corrosion is not necessarily the leaks alone, but it can also impact the heat exchangers, mainly the outdoor heat exchangers, which lead to poorer heat transfer efficiency, leading to high pressures, leading to the abnormal going out of the boundary limits of the design, which will create high pressures and leak. So this is something which we need to understand and address it appropriately.
Just to add, and I certainly agree with my colleagues who have covered the topic fairly comprehensively. Probably a couple of things just to add. The first one is that ISO 5149 covers off on the need to actually consider environmental factors in terms of both design and installation. And also the other element which we need to be conscious about is is where we've got materials which are incompatible. So, for example, in recent times, probably over the last couple of years in Australia, our experience has been that some of the pair coil that's used on outdoor piping has been installed A, inappropriately, and B, without actually having tested it, believe that it's actually starting to cause micro pitting, which has just been mentioned, or what we call more locally as ant nesting. And as a result, has ultimately meant that the copper piping has actually been ruined, and refrigerant has been able to escape. So there's a number of different criteria that you need to be conscious of in terms of the selection and location of equipment.
Okay. Thank you so much. And now the floor is open for everyone. And when you ask a question, if you are representing the country, please inform the country that you are representing, or if you are from organization, please also inform your organization. I think Marco, please, and then followed by India. Okay.
So there's someone else before me? No. So thank you very much. I'm Marco Buoni from the European Association of Installers, Technicians. It's called RAM. And of course, in Europe, we have some example to put on the table. We've been working on leak prevention, leak reduction for 20 years, since 2004 with the first F-gas regulation, with periodic inspections of systems. So you need to periodically inspect the systems. We have followed, to be honest, our Netherlands partners. STEC was a good standards, but already before, in the 90s, was starting leak reduction, leak checks, periodic inspections. But most of all, I think, this is my thinking, that the best result for leak reduction you can have from certification of technicians. So not only training, but certify the technician that is able to do this job, to do good brazing, to do good leak detection with a badge showing that is certified, so he can prove it. And also another point that is again my view, because as Association of Installers, we saw that brazing is very important, more than mechanical joints. We should prevent mechanical joints going to brazing, hermetically sealed equipment. The hermetically sealed equipment can give a good, push to prevent leakage. We have some graph in Europe showing how the reduction in leakage we had. We had in this room good consultant for European Commission that did these graphs, and we can prove that thanks to these 2 free tips, certification of technicians, periodic inspection, hermetically sealed system, we achieved a reduction in rates of refrigerants, leakage rates of refrigerants. Supermarkets are normally very, very leakage systems. They leak a lot because of long pipe work, a lot of brazing, a lot of mechanical joints. So probably you should face first that kind of sector to prevent leakages. But thanks to this free topic, brazing, periodic inspection, and certification, I think all categories, all application can be helped to prevent leakage.
I think you may like to add something, like following Marco intervention. Thank you.
Sure. Agreeing totally with you, Marco. The Australian, and there's a number of similarities between the Australian scheme, which has been around for 20 years, and the STEC scheme run by HBB. I would add, though, that the Australian scheme is a little different in the sense that it covers a broader range. It covers synthetic greenhouse gases as well. But it also relies on the wholesalers to play a really, really important part, and that is you need to be licensed to actually purchase refrigerant. That's a somewhat more difficult situation in the European circumstance. It's a little bit easier for Australia in the sense that we're an island. So it means that it's a lot more difficult to get refrigerant into Australia than it is to move it around in the EU. I would add that really there's 3 components to any successful licensing scheme. You touched on 2 of them. One being the competencies, and in Australia's example, you need to have what's called a Certificate 3, and that is generally 3 years worth of work to become get the base qualification to be to get licensed, and also as well as being competent, you need to obtain the license. The license is the thing where there is a level of compliance, and you need to have the equipment. So if you don't have the equipment, then you don't get the license as a business license. So there's that aspect. And the third part of the trilogy, which we sometimes tend to forget, and we've already talked about, is the codes and standards that these technicians need to actually work in accordance with and be aware of. And that's where the knowledge component comes in that you were talking about earlier. So whenever you consider about a license scheme, it's important to consider those 3 component parts. You can't separate them. They all work with each other in terms of a successful licensing scheme.
Can I just add one thing? Yeah. Thank you. My comment is not related to what Glenn just said, but you mentioned brazing being better than a torque joint or something like that. There's actually a very good study that was done almost 6 years ago, 7 years ago by Purdue University. So if you Google Purdue, P-U-R-D-U-E University, study on joints in refrigeration systems, they actually did the study with real technicians doing different kinds of joints, and they tested every one of them for leak tightness and so on. And it was a good study, and actually it'll support what you just said.
I do agree with, and everybody knows, and there's been spoken a lot and understood also well that certification is required. However, it is to be understood that the technology is changing fast, the refrigerants are changing fast, and a one-time certification and saying that he is certified for life is not a situation now, which was maybe there 25 years ago. And it is important that we address that. The second important point is after the certification, the technician, what tools he uses, and are those tools standardized? Are those tools checked and they are certified? That will also make a big difference. A very simple thing like a torque wrench, if it is not calibrated, then it can create problems. So we have to look at it in a very comprehensive way and just not stop at the certification. Also, whether these tools tackles instruments that they use, are they carrying a mark saying that it is calibrated well from the manufacturer? Are they of a good reputed brand who ensures that they are against certain standards? And whether such standards exist, say for a dial gauge, for a torque wrench, and do you have mechanisms to get those recalibrated, is also a thing that should be looked into.
Thank you. You want to add anything, Greg?
Yeah, if I can just add on that, I agree entirely. In the Australian example, we have 145,000 licenses. 25,000 of those are business licenses. The others are individual competency-based licenses. With the business licenses, they need to have the equipment that Jatinder was just referring to, and they're audited. We do 10,000 audits a year, and we look at the equipment to make sure that they are calibrated appropriately, as well as some other information about refrigerant purchased, returned, a whole range of different aspects as well. But definitely, things like making sure that cylinders are in date, that equipment's calibrated appropriately. So there's quite a bit that's built around that to make sure that that's the case and that equipment is working appropriately.
Thank you. Yeah, we have the floor for India's and then followed by Vanuatu and also Tuvalu. Okay, India first.
Thank you for the presentation. I heard that most of the leakage is due to the corrosion and due to the basically where SO2 emission is more or near to the seaside or H2S emission is there. Here I think that there is something wrong at the design stage, that the material is not basically used to sustain those type of environment. So here just I want to know that what measures to be taken during the manufacturing of equipment stage, any modification is required for the standard, or capacity building for manufacturer is required, capacity building for regulator is required, and what are the cost implications for doing this? Thank you.
Let me try, and then I think Jitendra and Glenn probably will have a lot more to add than I do. When you talk about special environments, the majority of the products that most people make, it all goes back to the specification for the design. If the specification calls for being in a corrosive environment, it will definitely add cost upfront because of designing for that corrosive environment, which is why most products are not necessarily designed for corrosive environment, because most people don't have corrosive environments. So special environments require special products. And I think Jitendra's point earlier was that even in a corrosive area, you could find places where the corrosiveness is minimized and then install your product over there. So I think the installation is also important. But bottom line, if you try to design for everybody in such a way that it works for everyone, then I think you will increase the cost, because majority of the people don't have that kind of environment. So I'll stop there. Jitendra and Glenn.
I agree entirely. I mean, it would mean that it would be cost prohibitive right across the whole board. But I think it's a conversation to be had with the manufacturer of the equipment to ask the question, okay, is this designed for that particular environment?
So three questions which have been asked is whether the technologies are available for coating. That itself is, to an extent, not in a foolproof way. Because even if we do coatings on the surfaces, that doesn't last for the entire life of the product. It lasts maybe somewhere between 3 years to 5 years. And the life of a product, if it is commercial, is 15, 20 years. If it is residential, it is about 10 to 15 years. So there is a need for an innovation on these coating technologies, as well as these coating technologies should be, how do we apply them in a mass production system is also to be looked into, and the manufacturing process innovation is required, which is there in some cases, which is not there in some cases. For example, the aluminum fins that are used in copper and aluminum heat exchangers, most of the manufacturers now use coated aluminum fins, and they have got good corrosion resistance. However, when the system is completely built, how do we coat the copper tubes? That is becoming a real challenge. Similarly, to have high efficiencies, the heat exchangers now adopted, or in most of the countries and will get adopted, are the microchannel heat exchangers, which are full aluminum. Though there is research being happening on new alloys and coating technology, I think there is a scope to add to it. Having said so, like what Rajan said, it is again an important that a technician understands that I am going to operate in a particular environment and I need to take care. So either he has to educate the customer that if you are going to install it here, you will require something to be done in addition to the standard equipment that is there. As far as the cost is concerned, if there is a technology available which can be adopted and implemented at a manufacturing level, the cost will be lower. If it is to be done at the field level, cost will go up, dramatically up. As well, the life of anything that is done in the field, because it's not a controlled atmosphere, there are no standards, it becomes, to an extent, the skill of the person who is doing it will become a challenge. I would say that with more and more warranty that is being offered by the manufacturers, they are doing their best to avoid the corrosion, but is it sufficient? No.
Thank you. I saw the floor from Vanuatu, Tuvalu, and Marshall Islands. Maybe we can start with
Sorry,
Vanuatu first.
one more question. I had not
Oh, sorry,
answered all
sorry.
of it. So you had asked for what should be done at a policy level. I think there is a requirement of development of standards on this subject, and at least to start with, develop guidelines and educate both manufacturers, technicians, as well as the consumers on this subject, followed by the standards, and whether they can be, it should be, whether it should be left to the manufacturers to be voluntary, that they take up this, or should it be made mandatory, which is like a regulated, that can be thought of. But definitely specific standard and guidelines needs to be developed. Yes, sorry.
Yeah, Vanuatu, please. Yeah.
Good afternoon, everyone. I'm Camilla from Vanuatu NOU. I would like to thank Mr. Rajan for a very comprehensive presentation. And I noticed that in your presentation, you mentioned the importance of installation and commissioning, and that trained competent service technicians play a crucial role in leak prevention. And that leads me to my question, which is what key elements should countries consider when incorporating leak management into competency certification for refrigeration and air conditioning technicians? Since in Vanuatu we are working with our TVET institutions on competency-based certification, and this would be helpful when we review our current certification system. Thank you.
Sure. Again, in the Australian experience, as part and parcel of the training that's associated with becoming a rack technician, it covers quite comprehensively the area of leak identification. And Rajan mentioned earlier a number of different ways that can be facilitated. Australia tends to take the view that the soapy water trick's not the best way to go about things. That it's preferable to use nitrogen and/or as a trace gas, and/or there's a couple of other ways as well. Electronic leak detectors are much more prevalent, has to be said, but definitely it needs to be a significant component of that training. It's not just the function of how you actually operate a vapor compression system. It's also about how you go about, as you touched on, commissioning, but more particularly fault finding as well. And that's one of the things that sets the trade apart from other trades, is the issue of fault finding. It's a slightly more comprehensive and specialist thing to do than a number of other trades. In Australia's circumstance, you even need a trainee licence, because obviously you can't emit refrigerant in any way, shape or form. So even as a student, you need to have a trainee licence to which you actually go through and you understand that you're not able to emit. So, and it has to be under the supervision of a teacher who is also licensed. But there's no question that there needs to be and certainly in Australia's case, there is a level of competency that gives people the understanding that they need to know about how to go about finding those faults, including leaks, and being able to fix them. The other thing in which is probably a little unique is that in Australia there's no topping up, not allowed to top up. You have to actually fix the problem first before you put refrigerant back into the system. So that's under the code of practice. And again, it's like I mentioned earlier, you can't really separate the issue of competence from the code of practice and standards, and also the behaviour aspect too, which is the licensing. So all that's covered as part and parcel of the fundamental training. I mentioned earlier that the Australian system, the training is nationally based and it's quite substantive. However, that brings with it some weaknesses as well, and that is that it's not as agile as what to get changes to keep up with technology, and sometimes the training tends to not necessarily follow the industry needs as much as what it could otherwise do. So that we all have challenges, and that's certainly one of ours. But getting back to your question, definitely that sort of aspect needs to be part and parcel and built into the training that they undertake.
I probably shouldn't say this, but I'll say it. I have an air conditioning unit at home that is now 18 years old and has not had a single problem so far. I probably jinxed it. But anyway, the reason why I say that is this. My neighbor is not so lucky. Why is that? It's not that I bought a better system than he did. It's not that I use my system better than he does. I think I paid for a good installer to install my system. And I don't know what he did. But the point is that when you install a system correctly and you commission it correctly, commissioning is extremely important. When you do those two things correctly, at the end of the first year, you'll know it. If a system is going to leak, if it's not going to work right, 1 year is all it takes for you to find out. If it works really well after the second year and the third year, it'll probably work well for the next 15, 20 years. That's usually how it goes with these systems, because all these systems have been designed very well. All these, I was talking to somebody earlier, that you take any of these air conditioning units from any of the manufacturers, it's very hard to find serious differences between them, serious flaws between them. They're all good. So what sets one apart from the other? It's usually how it's installed.
Just to add, a vehicle, if cleaned daily, if you service it regularly, it is going to perform. If it is not the same make, same model, is not going to. The real your question also was on management of leaks. I would say that one is training of the technicians, understanding, create awareness in the consumers is one, but we should also use technology. And most of the air conditioning systems today are driven by microprocessor-based controllers. And you're capturing a lot of data in terms of temperature, pressure, performance. And if we can process the data and get into a mode of preventive and predictive, like maintenance or predictive of what is likely to happen, then we can create a very early warning system to the end consumer or the customer himself, which will trigger him to call in for the technician to fix the problem, and not go the way of that my cooling is not coming, or if you're not using in a winter and if it is leaking, by the time you start in summer you find it is not working at all. Then you start the technician. So this is what we should do. And as Rajan again said, we do know that the amount of expenditure that is there on the installation is varying. It varies from 1.5–2% to maybe 25–30%. And we know that if you're paying less, or if the manufacturer himself is offering free installation, it is more likely to be of not to the standard what it is meant to be. And that is a management. So we can have a management of training, but also look at the technology and look at holistically of what is to be done.
Okay, thank you. And then Tuvalu, Marshall Islands, and gentleman at the back. Okay, Tuvalu first. Thank you.
Hello, everyone. My name is Moili, and I'm from the Tuvalu NOU. Before I ask my question, I want to thank the informative presentation and discussions. In very low-lying islands like Tuvalu, we are very exposed to the sea 24 hours in our everyday life. Hence, the lifetime of the rack equipment will only last a few years due to coastal corrosion. So thank you very much for sharing the strategies and the practices that we can adapt to minimize the corrosion of equipment. However, I believe that it could be a challenge and difficult in terms of accessibility to resources, but slowly we can achieve this. My question is based on flammable equipment. I find that technicians, in particular in my country, are very hesitant to provide services and maintenance on flammable rack equipment. What will be your advice on the steps that technicians can take to safely repair leaks in systems that use flammable refrigerants? Thank you.
I'll kick that off. Our licence scheme doesn't cover flammable refrigerants, but I've been involved in Papua New Guinea, and theirs does. What I would say is that under the Australian standard, if you're talking about retrofits, then there's sorry, I should say the ISO standard 5149. There is a requirement in there that needs to have an engineer have a look at the system to confirm that it is okay for being retrofitted with flammable refrigerants. So that's the first thing, and that's a big step away from what the previous standard talked about, which was a competent person, and there was no definition of competent person. So that's the first thing. If it's some of the flammable refrigerants have got a smaller molecule than fluorocarbon-based refrigerants, which means that leakage rates can be higher. Now, emissions aren't an issue with flammable refrigerants, generally speaking, but notwithstanding that, as you quite rightly point out, safety is. And it is fair to say that there are definitely requirements, just as there is for any type of refrigerant, of making sure that it's used in a safe manner, whether that be in the case of flammable refrigerants, whether it be in the case of CO2 under higher pressure, whether it be a case of ammonia as an asphyxiant. They all have their own set of criteria which need to be managed as part and parcel of their use. So to answer your question, flammable refrigerants certainly have a risk, there are a number of risks, and that's something that needs to be considered by the technician in terms of when he's using it. And if that technician is not familiar with on how to mitigate those risks, then he shouldn't be doing it, or she shouldn't be doing it.
One of the things that, at least in some countries, is especially these flammable equipment that you're talking about, they're all mostly for smaller pieces of equipment that can be hauled away. So one thing to consider is, should all the servicing, fixing leaks, should that be done in a central place, away from a residential area, away from a commercial shop floor or whatever, retail floor. Take it away to a safe place, and then have a few qualified technicians who can very specifically work on leaks from these. These flammable refrigerants that you're talking about, they're not in very, very large pieces of equipment. These are plug-and-play kind of equipment where you plug it in and turn it on. So you should be able to unplug it and perhaps move it to a central location. That's one thing to consider. But more than anything else, I think, as Glenn has said quite a few times already, there are standards that exist in many parts of the world that specifically address leaks, specifically address flammable refrigerants, and you may have to scour and collect all the appropriate things that you need to do for your country. That may be something that you have to do, not just simply adopt something that may not apply. Because the biggest problem that a technician is going to have is, which one do I follow? So.
That's a good point. I mean, charge sizes generally are quite small for a start. I would add that under the Australian training scheme, there is a couple of subjects in the training process which are specifically related to flammable refrigerants. I'm not suggesting you shouldn't use flammable refrigerants by any stretch of the imagination. My only point is that you need to be competent in their use to actually use them, that's all.
So just to add, it is important that we develop guidelines on how to handle in a very simple to understand language, maybe more pictorial, so that the standards which are there are brought down to an understanding level at the technician level. So, and your earlier comment that there is a lot of saline atmosphere and how do we tackle that? At a country level, again, either we made regulatory standards or at least to start with prepare guidelines on which will guide the buyers and the consumers to select of what it is. For example, the MEPS, that is minimum energy efficiency standards that are there in many countries, and in some countries there are levels. Some countries they have got star levels, which says 1 star is the lowest efficiency and 5 star is highest efficiency. In a similar way, if we can create some guiding factors which will say that it is not fit to be, or it has got a higher level of corrosion resistance, it is designed for a higher level of corrosion resistance. One is a medium level and one is a general purpose level. I think that will guide the consumers and the end users to select an appropriate thing. And once these guidelines, and if they are regulated, will come in picture, the manufacturers will definitely attempt to offer those products which have higher corrosion resistance.
Thank you. And just want to add more about the issue of the Pacific Alliance country. Like in the Pacific, there are 2 incidents like that. Flammable gas has been introduced to the country. The first circumstance is like when equipment has been designed for hydrocarbon. Even this one technician is still really, cautious on the safety. I don't have capacity. I'm not confident enough to do it. Another one that is a bit concern of the country is sometimes there's somebody who fly to the country and try to introduce hydrocarbon as a drop-in gas to HFC or HFC. And we always, educate the NOU that you need to talk to the technician that they are not supposed to retrofit equipment. That is not designed for flammable gas to be used with flammable gas. But even this one, they still have the challenge on appliance that has been designed for the flammable gas. And I think that Gren, Rajan, and you also mentioned a good point about the standard. And so if it's too difficult for technician to understand, maybe the guideline might do to help the technician to follow the good practices. Yeah. And we have the question from Marshall Islands and then followed by a gentleman at the back of the room. Okay, Marshall Islands, your turn, please.
Thank you, Pipet, and thank you, panelists, for the wonderful presentations and discussions. Before I ask my questions, my name is Jimson Laskan. I'm representing the Republic of the Marshall Islands, National Ozone Unit. I would like to give a brief background of the island community. So we've reported issues with the quality and durability of refrigerant-based HVAC units that are imported and sold in our local markets. Technicians and consumers often complain that these units have high failure rates and needs to be replaced every 6 months or either 1 or 2 years. In fact, Marshall Islands is very narrow, as some of our colleagues have visited our country. So the sea sprays and salt water really cause the damages to our equipment. So I guess my question is, what unique leak preventions considerations apply to these types of HVAC system compared to larger central systems? Second one, what factors contribute to the poor quality of refrigerant units being sold in the Pacific, and what can be done to improve the reliability and lifetime of these systems in the region? Thank you very much.
No, some of the questions, some of the things we have already discussed in the discussion earlier, so a few of them have been on a similar line. Questions were asked for. The important aspect is that is a technology available to take care of such issues? Yes. Is the technology deployed? Not necessarily. Generally, a technology doesn't get deployed unless it is to an extent regulated, or at least an awareness is there in the end consumer so that they ask for it and pull for that technology. In absence of it, we will get driven by the price consideration, and specifically the lowest price consideration. So what can be done in such condition is each of the country, for its specific requirements, maybe the guidelines can be prepared whereby and possibly regulated so that the equipment meets those requirements. And regulations definitely channelize the behavior both of the manufacturers also and the consumers also. So it will be a good approach to look into these aspects of creating guidelines, creating awareness, and also, as I said earlier, we have on a label today of a unit, be it a room air conditioner or a large air conditioner, we do specify what is the refrigerant use. We do specify what is the electrical connection voltage required. We do specify what is the capacity and what is the efficiency. If we are able to create that, to start with maybe only a 2 level, saying that, yes, this equipment can withstand higher corrosion resistance, and one is normal, that itself will trigger. Now, whether there are standards available for corrosion, they are, but are they specific to something? Not necessarily. So either we can adopt ISO standards as it is if the country wants to, or create their own standards. And I think this will channelize the entire thing. Also, the consumers do understand that if my equipment is failing in 6 months to 1 year time, the recurring cost is high, and if he has to pay something higher for a well-designed and well-built unit, he will be ready to do that.
Just, I have a question for you, because you said in 6 months the unit will fail. How does it fail? Does it fail because of corrosion or something else happens?
Thank you for your questions. It fails mainly due to corrosions.
Okay.
Yeah.
I wasn't clear, so that's the reason why I asked, because 6 months seems like a very short duration, but again, I know that in some places corrosion can be very intense. But given the kind of problem that you have, you could go the path that Jitendra was talking about. But as he was talking, a thought came to my mind, and I'll just say it without really having developed it much. In the United States, we have minimum efficiency standards, okay, for products. But then, as an incentive, so everybody has to meet that, right? But as an incentive for a higher price point, they have this thing called Energy Star. I wonder if maybe there is something like that that you could consider for your country, you know, where if Jitendra comes with a product that lasts 6 months, and then I come to you and say, let me see if I can get this quote-unquote corrosion star product that'll last 6 years. And maybe the customer might be willing to pay an extra few dollars for that. You know, that's an incentive program that you implement where you have certain standards that people have to follow in order to meet this star label. Then my product will have that star label, his will not. And maybe the consumer can be educated to look for that star label. That's how you could also drive the entire market to higher and higher standards. It's just a thought.
So just to add, you said corrosion. I'm sure that the corrosion is happening on the heat exchanger fins and they get disintegrated very fast. I can state here that the Indian Railways have got their own specifications where their heat exchangers have to be copper tube, copper fins, tin coated. And that is the standard. You cannot offer standard product to them because they want the units to last for at least 15, 20 years. The trains within India will go across. They will go from hot climate to cold climate, saline atmosphere to dry, high humid, and you don't know where all they pass through. So this is a proven example that how we can overcome that.
Just to add that if you move in a way which actually you introduce requirements across the country, then you're creating a market. If you do individually, then you'll struggle to get manufacturers to move into that space. But on a countrywide basis, regardless of the size of the country, you've got more of a chance that the manufacturers will actually service your needs.
Okay, thank you. And now, may I invite the gentleman at the back of the room to ask a question? Thank you.
And thank you for a wonderful panel session. It was so good, I've come back again.
No, you have to hold the microphone very close to you.
Very close. Is that better? I don't think it's switched on.
You can sit in the chair and use one of it.
Just sit here?
Use one of these. Yeah, thank you.
All right. I'll give you the compliment again. Oh, okay, that's better. Thank you for a wonderful session, and it was so good that I thought I'd come back again. So thanks very much. I'd just like to pivot here and just talk about commercial refrigeration, if we could. And so it's probably a question to Raj and Jitendra. If you could just give us your thoughts on the reasons why commercial refrigeration have such high leak rates. And then the second question would be, what would you do to reduce those leak rates in an economy?
You certainly know the answer better than I do,
like
but
to discuss it.
I'll give it a shot and then we can have this discussion. Why do commercial refrigeration equipment have high leak rates regardless of where they are? The larger systems have greater leak rates than smaller systems. You know, earlier I mentioned plug and play. Basically, you plug it in and flip a switch and the system runs. Those usually have very low charge. Low charge systems are, in HVAC&R language, they are critically charged systems. That means you don't have an ounce of refrigerant more and you don't have an ounce less. It is precisely what it's supposed to be. They tend to be factory charged, correctly charged, and they operate the way they're supposed to operate. When they lose even 1%, 2% of charge, it shows in the performance. it doesn't keep cold. And so you immediately call the technician and come and take a look at this, see what's happening. Those very large systems that we talk about in grocery stores, they could have, 100, 200, 300, 400, 500 in the United States. They probably have 1,500 kilograms per system. Per system, 1,500 kilograms. They have a buffer in there in the sense that if it's 1,500, you could go from 1,500 down to 1,400, and the system is still running. The lines are long. There is enough forgiveness in the system. You could drop down to 1,300 kilograms. You've lost 200 kilograms now, and the system is still running. What happens at that point is if one refrigeration case is not running correctly, what do you think that grocery store owner is going to do? He's going to move stuff from that case to the next case and carry on. This case is not going to be populated as much. So there is lots of cases, lots of refrigerant, lots of copper piping, et cetera, and lots of refrigerant. There is enough buffer that a small leak, 5%, 10%, is not noticed, which is why you need all those indirect methods, which is why you need all those automatic leak detection systems, because they would catch it. That's one reason. The other reason, which I will say, and then I will stop, turn it over to these two gentlemen, is many of these grocery stores, if they're not air conditioning the store properly, and I use the word air conditioning in very general terms, it's not just temperature, but it's also humidity. Guess which piece of equipment acts as a dehumidifier now? The refrigerator case. Your evaporator coils in the refrigerator case are now acting as a dehumidifier for your entire store. And so all the moisture, the water, everything is collecting there. So that is when you start getting into, I don't know, we keep coming back to this C word, corrosion. Corrosion failures begin to happen, okay? So I think if you design the store correctly, you'll make sure that the humidity in the store is always correct, the temperature in the store is always correct. You'd also make sure that you have automatic leak detection, you have preventive maintenance happening, you make sure that you detect what is a refrigerant in the liquid receiver. If that refrigerant level in the liquid receiver drops by more than X%, you better alarm and stop what you're doing and go take care of it. Those are all the reasons, that I can tell. Commercial refrigeration equipment that is small, no. That is just like air conditioning equipment. The moment you lose a little bit, everybody knows about it. So I'll stop there.
Okay. I think we need to understand whether it is a technology problem, implementation problem, or a management problem. And why I say so, because a similar set of a large charge, which Rajan mentioned, and a distribution as what it is there in the VRF systems. You've got one outdoor system and actually multiple outdoor systems coupled, and they cater up to, minimum 60, 70 indoor units. But to the best of my knowledge, the leakage is far less than that in a refrigeration system. The pressures will be similar or maybe lower, okay? So I think it is all related to the management. And why I say so is a VRF manufacturer usually has got a software which tells you how the piping is to be there, how piping size is to be there, what types of T connections, or actually they are not T connections, they call it as a ref joints, the Y joints, how they are connected. In many cases, the manufacturer of a VRF system insists that even the Y joints has to be bought from either himself or recommended certified standardized things. though I have got a much lower experience in installation of a refrigerant system, I think the problem lies to an extent there, where whether VRF systems, because there is so much of electronics involved in that and so much of balancing has to be done, will be commissioned by engineers, not the technicians. I'm making this difference. And then he goes. Also, the practices that are followed for holding the pressurized system for 24 hours before they release the charge and start the unit are different. Whether similar practices followed in refrigeration, whether the engineers are commissioning or it is left to the technician, we should look into it. Technology-wise, they should not, because it is not only one-to-one or factory sealed system. There are air conditioning systems which are available with the complexity of that nature only.
You've done a wonderful job so far, guys.
Just to add that for those of you who were here at the previous session, I made reference to a report that was undertaken by the expert group, which is now available and has been for some time. I think it was done in 2021 on leakage rates in air conditioning and refrigeration equipment. Peter happens to be the author, the person who's asking the question. So I thought I might take this opportunity to throw to Peter and say, have you got any thoughts about your own question?
Before Peter answers, I want to say one more thing. And that is, I think he'll agree with me on this. I may sound like a broken record, but I'm going to say it anyway. The big difference between many of these HVAC systems and the small plug-and-play systems and the larger systems that we're talking about, where you have leakage rate of 10, 15, 20, and even 25%, the big difference between those two is these larger systems are 100% field installed. Yes. Okay? They're all installed in the field, they're assembled in the field, and therefore, they're all one-off, like we talk about. Yep. Okay, no two systems are alike. Whereas these VRV systems that you're talking about, they make 1 million of those, okay? They make one of the system that Peter is asking about. That's it. And that one system is made and built on site. And that's part of our problem.
Actually, I wanted to add exactly same thing. It is field assembled system with not necessarily all the indoor and outdoor units coming from the one source.
That's correct.
Very important. You don't know how you're matching it and who is in charge of the design. Yeah. It is not a grand plan which is implemented, but the local persons who is a consultant contractor who is doing the job. And I think the issue lies there.
Am I back on? Or? Can you hear me? Oh, yes. Well, firstly, I think that was a fantastic answer from the panel. You've covered you've covered the overwhelming majority of all the aspects, and particularly your last discussion about the distinction between air conditioning and refrigeration is that air conditioning systems, particularly today, manufactured on such a large scale by regional and global manufacturers that they're such a high quality, and then ultimately all it's down to is 4 connections. So you have 4 connections, and a good technician will probably solder 2 of those connections. So you're just down to 2 connections. So you've got 2 leak points if the manufacturer is doing a really good job. Whereas with a refrigeration system that is a one-off custom, with the evaporator coming from one supplier, the condensing unit coming from another supplier, and the other aspect that's just worthwhile talking about is is perhaps a refrigeration system and a remote refrigeration system with a couple of evaporators hanging off it in a cold room or something like that might have, or a mobile refrigeration or marine system, it might have 40 connections. And I think it's those 40 connections, or in some systems just 10 or 20. They've got a lot more opportunities for leaking, and they'll have service valves, and certainly what we've found in this more recent study is that technology is on our side, where particularly in Australia they're leaving their gauges in the vans, and they're using electronic technology to diagnose their systems, and so that means that they're not actually hooking up the gauges to the Schrader valves, which is another leak point. They're not hooking their gauges up to to the service valves where they've got connection points. So ultimately, we might get to a stage where we could, if we took another look at the design of commercial refrigeration, we could, based on current technology, we could probably take a lot of lessons from air conditioning and eliminate a lot of those leaks, and we'd be in a much better place. So our current assessment is that leak rates of air conditioners, because of those two connection points and those wonderful quality systems, is about 4% per annum across the fleet of air conditioners in Australia, and that's the R410A systems. I'm not talking about the new 32 systems where they're a newer fleet. The leak rates of those will be less. Whereas with refrigeration systems, we can't reconcile the numbers without coming up with a leak rate in commercial refrigeration of around 15%. All right, and we've got, we think that we've got reasonably skilled technicians, and we've got a leak rate of 15%. And then add the fact that the refrigerant is, is typically 404, so the potency of those leaks is probably 20 times more. And so it really shines the spotlight on the opportunity with commercial refrigeration system. I think air conditioners have come a long way, but I think commercial refrigeration have need to go on that same journey.
Thanks so much. And okay, we are, running out of time now, and we are over by 10 minutes. Now we can conclude the section, and I would like to thank our expert, Rajan, Gren, and also Jitendra for your excellent information and also advice to the participant. And also thanks for everyone for your question, your contribution, and thanks also Secretariat for arranging this section, and thanks for our SCAT team who have very excellent preparation of the facility. And we can close for now, and please enjoy your coffee break, and we will come back to the plenary at 4:15. Thank you, and enjoy your coffee break. Thank you.